Yep, so we're going to go over the handout for week 1, day 1. So the thing I just handed out to you, and you'll find the electronic files in Professionalism 1. Same title, week 1, day 1. And then I'll post this after. All right, decimal places. So after the decimal place, it's going to be less than 1, right? So anything on this side of the decimal place is going to be greater than 1. So it's going to end with an S. So we got the ones, tens, hundreds, thousands, 10,000s, etc. Anything on this side of the decimal place is going to end in THS. So that lets you know which side of the decimal place it is in. So this side starts with the tenths, hundreds, thousands, tens thousands, hundred thousands, millions, right? So THS lets you know it's less than 1. Anything that ends in S, greater than 1. So let's see here. Let's do 4, 9, 7, 8, 6, 3, 2, 4. Sorry, got a 4. I'll do a 5 now. 7, 9. All right. I'm just fill in these numbers, and let's do some rounding. Right? So how do you round? What's the first thing you have to do when you round? Yeah, you got to find the decimal place in question, right? So first you got to find the decimal place in question. Now you know the names of the decimal places, you can find them, right? So if I say ones, yeah, you'll look right about there. If I say hundreds, you'll look here. But to determine if you round up or down, you're going to look to the right of the decimal place. So you got to look one decimal place over to the right, and that number will determine if you round up or down. So if it is a 0 through 4, you're going to round down. So the number in question stays the same. Everything after it becomes a 0. That's how we round down. If the number to the right is 5 through 9, we're going to round up. That means the number in question increases by 1. Everything else after that is 0. So you guys ready to do some rounding? All right, so let's fill in some numbers. 9, 2, 7, 6, 8, 0, 7, 5, 3, 2. All right. I think that number should work. All right, so let's take a look at the nearest tenths. So what number is in the tenths position? 6. So where do you look? You look to the right, and it's an 8. So what happens to the 6? It goes up, right? So you document the number as 9, 2, 7, 7, 0. Right? That's it. Round it to the nearest tenths. 68 is closer to 70 than it is to 60, right? Everyone agrees? 68 is way closer to 70 than it is to 60. Tenths. What digit is in the nearest tenths?
0.
0. Here it is. So we got to look to the right. So the right is a 7. Do we round up or down? Up. So the number becomes 9, 2, 7, 6, 8, 1. All right. What number is in the whatever place that is? What number is it? 5. Yeah. So this is the same way of saying tenths, hundreds, thousands, right? So now we're looking at thousands. This number is in question now. And we look to the right. This time it is a 3. Do we round up or down? Round down. So 9, 2, 7, 6, 8.07, and the 5 stays the same. It's everything else after it that becomes 0. And we don't even write it. What number's in the hundreds? 7. Right? And all you do is you look to the right, it's a 6, so the 7 is going to become an 8. There you go. Not too bad?
For testing purposes, okay, if you're requesting us to round it to the nearest 100s, are we gonna, do you want it to stop at the hundreds, or do you want it to continue to the tens and the ones? Like, do we need to put the
decimal?
Very good question. Why didn't you guys ask me that earlier? Medical notation. Everything in medical notation. So what is medical notation for numbers?
It's always
1
going
cricket,
to
2 cricket, 3 crickets, 4
You're
cricket.
always gonna have, it's not the same as
You always have to have a 0 in front of the decimal. So any number less than 1, you have to have a 0 in front.
for dosage purposes, correct?
Yeah, for testing and for when you're charting. If you have any zeros after the decimal, we leave them out. No trailing zeros. You must have a 0 in front of a decimal. Can't just have a naked decimal point, because that might be mistaken for just 5. So you have to put a 0 in front. Any zeros after the decimal, you leave off. No trailing zeros. So that's what I mean by medical notation. So all numbers that you enter in any exam must be in proper medical notation. Scientific notation. So scientific notation is expressing any number, big or small. That way we don't have to write out all the zeros, between 1 and 10, and you multiply it by a power of 10. Right? So you're going to convert whatever number you have between 1 and 10, and then you're going to multiply it by 10 to the whatever power. Right? So what is 10 to the first power? What's 10 to the second?
10 times itself, 10 times
10
10.
to the third, all right, very good. 10 to the fourth. So you said 10 to the second is 10 times 10, which is 100, right? 10 to the third is 10 times 10 times 10, which is that. This is 10 times 10 times 10 times 10. What's this guy? Just 10. And then what's 10 to the 0? What's 10 to the 0? What's 10 to the 0? So I took off a 0 here. Right? I took off a 0. Very good. Huh. He recognized patterns, sequences. So 10 to the 0 is 1. So all we're doing is we're going to move the decimal point, and then we're going to multiply by a power of 10. So here's 250. Here's the decimal point, right? So I need to move it over here. So I'm going to change it to 2.5 times 10 to the what? 2 decimal places. How many decimal places? There you go. So if you're in doubt, just punch it in your calculator. 2.5 times 10 times 10. Make sure you get 250. So if you go this way, it looks like you're going to have a positive exponent. Punch it in. You guys get it? Yeah, 250. Yeah. So for B, I want this decimal place now 1, 2, 3 places, but I'm going this way, so it's going to be a negative exponent. The number between 1 and 10 is 1.5 times 10 to the 1, 2, 3, the negative 3 negative. 10 to the negative 3. So let's see. What's 10 to the negative 1? What's 10 to the negative 2? What's 10 to the negative 3? Let's see if you guys can follow the pattern. So we got 10 to the 0, which is 1. So what's 10 to the negative 1? Just 0.1. What's 10 to the negative 2? There you go. You were just early. So this would be 0.001. All right, now you know the exponent. You can express it as a decimal, and you can express it as a fraction. We'll get to that. All right, C. What do you guys get for C? 9.5 times 10 to the, how many? 10 to the, well, I moved it 1, 2, 3. So yeah, to the third. D. 5.3 times 10 to the 1, 2, 3, 4, 5. Yeah, negative 5 though. All right, negative 5. Remember, if you move that way, negative 5. So what's E gonna be? 8 times 10 to the negative what? 8? Everyone got 8? So let's see. 1, 2, 3, 4, 5, 6. Uh-oh. I got 7. 7. Tenfold overdose. Think the patient lived? Maybe. I don't know. We'll see. Try it. Try it out there. All right. F. 7.84 times 10 to the 1, 2, 3, 4, 5, 6. No, that's not between 1 and 10. All right, you need a number between 1 and 10. So it's 1, 2, 3, 4, 5, 6, 7. And lastly, G, 8.24 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. So additionally, when you're documenting numbers, all you need is the decimal point. So no commas, and you don't need the units. The units will be in the question. So just put in the numerical value. Please excuse my dear Aunt Sally. So do parentheses and exponents from left to right, multiplication and division from left to right, and then you do addition and subtraction from left to right. All right, let's get some volunteers up on the board. So thank you everybody for sending your info. So I'll do the first one, and then I'll get volunteers for the subsequent ones. All right, so I'll do the first one. So A and B, the only difference is the addition of the parentheses. Same with C and D, where they are positioned. All right. So I'll do this first one, and then I'll get volunteers for B, C, and D. So in A, what can we do first? Parentheses and exponents, do we have any? No. No, all right, so you're right. Let's go to multiplication. So let's do one step at a time from left to right. So what does this guy become? 1.5. So I rewrite everything. You guys don't have to. But if you skip steps and if you don't rewrite everything, you might miss something. So I'm just going to rewrite everything. All right, what's the next thing we can do? Yep, so 1.5 plus 10 minus 10. All right, now we're just left with addition and subtraction, right? So we can just do it from left to right. 1.5 plus 10 minus 10 equals 1.5. There we go. That's not right. B, C, D, B, sir, C, B, C, and D. The volunteers will do theirs on the board. Inside the parentheses. So do this guy first. Yeah. Oh, so rewrite everything. Put the parentheses in as well. Yeah. And then everything. So this is what. So this. Yeah, this becomes that. Rewrite everything else. Just delete this. Minus 10 parentheses. Right? So the only thing you did was this, it became that. Everything else did. Now you're next to it. All right. Everybody ready? Done?
I think so. And I'm getting minus 3.5.
Okay, good. Uh-oh.
I don't know.
All right, let's see B.
Math is not my forte.
So B, on B, the first thing we need to do is parentheses, the addition. So very good. And then after we do the parentheses, we get that weird nasty number. So 0.5 times 203 gives us 101.5, and then you divide that by 20, all right? So you have to divide that by 20 before, so good, divide by 20 before you subtract, so you get a negative, what'd you get, a negative 4?
Negative 4.925.
Negative 4.925, so very good.
Can we round that off?
For this exercise, don't worry about it. So that looks about right.
Totally wrong, probably, but.
All right, for C, the first thing we do for C is in the parentheses. So we're going to divide 200 by 20. So that's going to give us 10. So still inside the parentheses. Right. So now we do the 3 plus 10 inside the parentheses. It becomes 13. So multiplication versus subtraction, what do we do first? Multiplication. So we have to do the 0.5 times the 13 minus 10 equals 3.5. There you go. And then lastly, for D, we have a bunch in the parentheses, but we'll do the division first. So that becomes this 10 right here. So inside the parentheses, we have 3 plus 10 minus 10. That just simplifies to 3. Then you get 0.5 times 3, which is 1.5. So parentheses, orders of operations are very important. You can see that if we have parentheses in different places, your answer will come up differently. All right, so keep that in mind when you're crunching numbers. All right, for these, it's a practice in adding, subtracting, multiplying, and dividing in scientific notation. So notice everything is in scientific notation. So when you add and subtract, you got to line up the decimal point. So we have to do it the long way. There's no way out of it. So going backwards, if it's a positive exponent, which way do I move the decimal point? Who said right? Who said left? Right. Those who said right convinced those who said left. Those who said left convinced those who said right. So we gotta go to make a bigger number, right? We gotta make it a bigger number. So which way are you going? Oh, see? Your left or my left? Your so I don't like left and right. I just say, does it become bigger or smaller, right? That makes more sense. So if you're multiplying by a positive exponent, the number's going to get way bigger. So it's 5. 1, 2, 3, 4, 5. So there's the decimal point. And you're going to add it to 159, right? So this time we're only moving it 1, 2. All right. So punch those numbers in. You have to line up the decimal point in order to do addition and subtraction. So what do you get here? 1, 2, 0. Come on, you guys got the calculators?
0, 159.
Yeah, simple addition. All right, B. 6.8 times 10 to the negative 2. This time the decimal point's going to go the other way. So it's going to make the number a little bit smaller.
1068.
There you go. Very good. 2 places. 1, 2. And then you're going to subtract it from 0.0047. Very good. 1, 2, 3 decimal point. So you just learned scientific notation. Here we're just going a little bit backwards. Line up the decimal point and subtract. All right. C. When you multiply powers of 10, you add the exponents. So what you have here is 9.3 times 3.2 times 10 to the, oh, I got a negative 1 and a 5. Add those together. What do you get? 4. There you go. And you're done. All right. So 9.3 times 3.2 times 10 to the 4. Right? So that's the slick way. You can revert back. You can regress back to the easy stuff. You can just change this to a decimal. Whichever way is easier for you. Right? So, oh yeah. Why didn't anybody say anything earlier? There you go. So for that one, you can do it either way. You can add the exponents, or you can just convert to a decimal and multiply. Either way, what answer do you guys get?
297,600.
297,600. So for division of power to the 10, you're gonna subtract exponent. So this is going to be 8.15 times 4.2 times, what is 7 minus negative 3? What do you talk about?
10.
Yeah, because you subtract a negative number, you add it. Yeah. So again, you can revert back 815 divided by 0.0042 if you like, dealing with a bunch of zeros. Either way, your answer is going to come out to be something gigantic, something huge, right? So write it in scientific notation. .15 times 4.2 times big ol' number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equals 3.423 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, what does this equal? 8.15 times 4.2. Yeah, that's right. 34.23 times 10 to the 10. Move this guy over 1. This guy becomes 11. Yeah, that's good. No worries, just change everything to decimals and write out all those zeros. Remember, your calculator gets bigger if you turn it landscape. It becomes scientific. Fractions, decimal percentages. It's 3 ways of expressing the same value. So technically, fraction equals a decimal equal percentage, and if you want to get technical, you can throw in ratios as well. All right, fraction to decimal. What's the top number called? Good. What's the bottom number called? How do you go from fraction to decimal? Yeah, just divide. So that fraction bar is a division sign. So for 3/5, we take 3 divided by 5. And in medical notation, how would you document that? 0.6, right? So make sure you have a decimal in front, or 0 in front of the decimal point. Percent. What does cent mean to you? How many cent in a dollar? How many centimeters in a meter? So cent means 100. Percent means per 100. There you go. So take your decimal and you multiply by 100. 0.6 becomes, so for the homework, you don't have to put the percent symbol. Just put the numerical value, 60. All right, number 2. What is 1 divided by 18?
0, 5, 5, 5, 5.
Yeah, a bunch of i's. We'll put a couple 5s in for fun. All right, how do we go to percentage? What do we end up with?
55.55.
Yeah, very good. This time for number 3, we're starting off with decimal. So we can go this way, nice and easy. What does that guy become?
He becomes
0.16 times 100? Yeah, times 100. Don't forget, times 100. All right, now we got to make a fraction. So we got to look at the last decimal place. The 6. What decimal place is the 6 in? So we got tenths, hundreds, thousands, 10,000. So your denominator is 10,000. What number are you going to put on top? That's it. How do you check your work?
You just divide the 16th over the 10,000.
Yeah. So punch that in. All right, do 16 divided by 10,000. In this class, you don't have to reduce to lowest terms. So just leave it as is. So does it equal?
Yes.
Okay. So that's the easiest way to go from decimal to fraction. Other classes, you might have to reduce. This one, not so much. 4. Let's go this way first. What does this become? Yeah. Let's do the fraction. So what's going to be the denominator? 3. What decimal place is the 3 in? So count them. Tens, hundreds, thousand. What number goes on top? 13? That's it? Double check your work. See if you put 13 or what goes on top?
118.
Just 113? Okay, try that. Punch that in. See if you get that. You're missing a digit. Don't leave out his friend. There you go. All the digits. So just 1, 1, 1, 3, and then double check. All right, don't be scared that it's over 1. You just do the same method. So does that work? Okay, good. Now we're starting with percentage. To go backwards instead of multiplying, what are we going to do? We're going to divide by 100. So this becomes 0.00056. Let's take a look at this 6. We got tens, hundreds, thousands, 10,000s, 100,000. And that's it, 56 over 100,000. Double check your work to verify your decimal. All right, conversions. Conversions are easy as long as you have the conversion factors. So we'll use the conversion factors given in these lectures and handouts. So as long as you have the conversion factor, it's real easy. Either you multiply or divide. That's it. So to go from meters to inches, hey, where's mine? Yeah, what is it? Dr. You know what? I want a vanilla Coke. Do they make those anymore? Because they add extra sugar. I saw a regular Coke, vanilla Coke, and it was like 10 extra grams of sweetness. Vanilla Coke? No, I'm okay. So that's it. Either you multiply or divide. So for A, meters and inches. Is there a conversion factor meters to inches? Right there. So do you want to multiply by 39.36 or divide? A meter has about 39 inches. Do you multiply or divide? Okay. Those who say multiply, convince those who said divide. Those who said divide, convince those who say multiply. So what you're going to do is you're going to multiply. So you guys know how to set up proportions? Left wing equals right wing. So if I have 1 meter, then that's equal to about 39 inches. then I know for 2.5 meters, that's going to equal to X inches. Do you guys remember doing cross multiplying? And then this wing is equal to that wing, right? You guys remember? So 1 meter times X equals, well, 2.5 meters times 39 inches, right? So for this one, all you do is multiply. You take 2.5 times, right? How many of you guys are familiar with cross multiplying? Okay. So that has its limitations. What I like doing is I like to multiply or divide by 1. So 1 meter over 39.37 inches, what does that equal?
98.425.
No, that equals 1. If I take 39.39 inches, 37 inches, and I divide that by 1 meter, what does that give me? 1, right? So the units change the value of the number. So if 1 meter equals 39 inches, and I divide it by itself, what does that equal? That equals 1, right? Because what can I convert this into? I can convert this into 1 meter. What's 1 meter divided by 1 meter? 1. I can convert this 1 meter in 39.37 inches. That equals to 1. So we're going to use this property of 1 to set up if you're going to multiply or divide, right? So if you don't know how to cross multiply, you can try this. So what I do is I take my units in question, put it over 1. That's just a placeholder. And the version I'm going to use of my conversion factor, these units here tell me what units I want at the bottom because they need to cancel out. So for every 1 meter, there are 39.37 inches. Do you guys know how to multiply fractions? So multiplying fractions is easy. Take all the numbers on top, multiply those together, divided by all the numbers at the bottom. So you would take 2.5 times 39 over 1 times 1. So that just simplifies to 2.5 times 39.7. All right, so let's do a couple more examples. Hopefully you guys can pick up the flow and the pattern. So that's all life is, about recognizing patterns. All right, inches to meters. Do we have a conversion factor, inches to meters? The same one, right? Yeah.
For the first one, so what we read there, would that be the one on the way on the top right?
This one right here?
So, yeah,
Simplify it.
yeah, that's what we would put for the answer?
No, simplify it.
Oh, okay.
Oh, we simplified 39.37.
98.42.
Yeah, so what's your final answer? 2.5 meters is how many?
98.425 inches.
Yep. So you get about 80, yeah, about 98.42. So as long as you get 98.42, you're fine. Either method you use, cross multiplying or using your dimensional analysis. All right, so for B, we have 125 inches. So I just put that over 1. This time I want my inches in the denominator. So for every 39.37 inches, I know there's 1 meter. So for this one, all you do is divide. You take 125 and you divide. 125 inches divided by 39.37. And you're done. Inches cancel out and you are left with meters. So what's 125 inches divided by 39.37? Okay, so about 3.1, 3.2. So don't worry about your decimal point and rounding. Here we're just learning the methods and processes. Meters to feet. What's our conversion factor? 3.28. Are we going to multiply or divide by 3.28? All right, let's set it up. We want inches at the bottom, right? So they can cancel out. no, sorry. 3.28. I'm looking at the wrong thing. 3.28. Let me start over. 0.8 meters. I'm looking at the wrong thing, sorry. And for every 1 meter, there is 3.28 feet. There you go. Sorry about that. A little brain fart. So in this case, we multiply. 0.8 times 3.28 over 1 times 1. Those ones you can just ignore. So for this guy, you multiply by the conversion factor. So 0.8 times 3.28 gives you 624, something like that. All right, this time, are you going to multiply or divide by your conversion factor? So we want feet at the bottom. So the 3.28 feet at the bottom equals 1 meter. Yep. So we divide this time. So 43 divided by 3.28 will give you about 13.9. Not too bad? I'm going to give you guys something to do on your own, right? So either you multiply or divide by the conversion factor. That's it. Your job is to figure out which it is. Inches to centimeters. Do you multiply or divide? So everyone try this on your own. Either method. Multiply or divide?
Multiply.
Very good. So take 56 inches, multiply by 2.54. What do you get?
14.1.
All right, very good. B, our conversion factor, kilograms to pounds, is 2.2. Are you going to multiply or divide? All right, let's set it up. So we want kgs at the bottom. For 1 kg, there's 2.2 lbs. Very good. You multiply by 2.2. So 0.05 kilos is how many pounds? How much? 0.11. So don't forget your 0 in front of the decimal. All right, so for this guy, you multiply it by 2.2. Pounds to kilos. Multiply or divide? Yep, 87 lbs over 1. We want lbs down here. So that's 2.2 lbs for every kg. So for this guy, you divide by 2.2. 87? How many?
39.54.
All right, 39.54 abouts. And let's do this last one. 60 grams. We want grams at the bottom. So for every 28.35 grams, you get 1 OZ. So we divide by the conversion factor. 60 divided by 28.35 gives you 2.11. All right. Not too bad. Still with us? Conversions? Multiply or divide. As long as you have the conversion factor, it makes it easy. All right, let's get into the algebra. So now you're going to have to plug and chug. IE ratio. I is inhalation time. E is expiration time. So it's a good ratio comparing inhalation time to expiration time. So it's I to E. So the I component is here, right? So all you do is take, yeah, E is expiration time. I, inhalation time. So I is easy. I is just inhalation time over inhalation time, which should be just 1, right? So you're always going to have a ratio 1 to something else. And now you have the E component, which is the expiration time over the inhalation time. All you got to do is plug and chug. Right? So for A, inspiration is 1, expiration is 2. So you just plug in 1 over 1 to 2 over 1. And then you simplify your fractions. What's 1 divided by 1? All right, what's 2 divided by 1? 2. Telling me or asking me? No. So it's just going to be a ratio of 1 to 2. All right, B, all you got to do is plug and chug. 1.25 over 1.25, and that's compared to 3.75 over 1.25. So simplify these numbers. What ratio do you get? 1 to punch it in.
1.25 3.
Yep, that's going to be a 1 to 3 ratio. Okay. C, we'll do the same. 0.75 over 0. You don't even have to do this part now, right? You can just skip this part. The only thing that's important is this guy. Right? So let's forget about that. I know it's going to be 1 to something. Let's just do the second part. Save us a little bit of time. 2.5 over 0.75. So that's about, okay, 3.3 maybe. All right, let's go backwards. Now I give you the ratio and inhalation time. You tell me what the expiration time is. So the equation that's going to be important is E equals the expiration time over the inhalation time, right? So all we're doing is this part right here. E equals T over Ti. So let's plug and chug. So what is our E value? 4. Right. What is our inspiration time? 1. So TE. All right. What number divided by 1 will give you 4? 4. There you go. T equals 4 seconds. That's it. And just solve for it. So just multiply both sides by 1 to get rid of the 1, I guess. That way the 1 cancels out. So T equals 4. Easy enough. That's A. B. We're going to do it the exact same strategy. Right? So the number that's important is this one. So we got 3 equals Ti is 0.5. 0.5. So TE must be what? What number divided by 0.5 will give you 3? 6 seconds? Are you sure?
That's what I calculated. That's what I did.
1.5. Alright, so plug that in. 1.5 divided by 0.5. Does that equal 3? Right, that's what you're solving for. Better equal 3. And then if you're not sure, just plug it in. Alright? What's 1.5 divided by 0.5? Gives you 3. Alright, here we're going to change it up on you a little bit. This time we've given you the E value. So, still, the number important, that's this one. Oh, that's B, this is C. So, 2 equals, this time they gave us the E value. 1.5 over inhalation. Okay, what inhalation time would give you 2? 1.5 divided by what number will give you 2?
0.75.
Very good. So you're just solving for this value. So plug it in. Make sure your ratios correspond.
We always have to put that 0 before the
Decimal place, yeah. Yeah, for medical notation. Get in the habit of it, because when you chart, you have to put a 0 in front. All right, let's do some blending of air. So, how much oxygen is in this air right now that you're breathing? You're sucking in right now. How much of it is oxygen? How much of it is oxygen? It's about 21%, all right? So the rest of it's mostly nitrogen, a little bit of other gases. Now, if you had an oxygen source from a tank, what percent oxygen is that? 100%. So you got 20% from the atmosphere plus 100, but the doctor doesn't want you to give them pure 100 or just 20%. They want to give you, in this case, 28%. So you're going to have to turn both dials on. How much air, how much pure oxygen in order to get the correct oxygen mixture. So they call that the air-oxygen ratio. So just plug and chug. That's all it is. So you're going to plug in the desired oxygen, 100 minus the desired oxygen, divided by the desired oxygen minus 21, because that's what's in the atmosphere. So let's plug that in. So we got 100. So for A, we got 100 minus the desired, which is 28. And then we got 28 minus 21. So this gives us, what is that, 72 divided by 7. So it's going to be about a 1 to 10 point, yeah, about 10.28. So air is at a 1 ratio. All right, let's try 30. So you take 100 over 100 minus the desired, which is 30, over the desired, which is 30 minus 21. So 70 over 9. So 70 divided by 9 equals?
7.77.
Yeah, about 7.77. We are still below the threshold. So the threshold is 35%. So since we're below 35%, this number stays 21. So if we ever reach a desired 35 or greater, we change it to 20. So for 34, we're still going to use the 21. So C, we got 100 minus 34 over 34 minus 21. 66 divided by 13.
5.07.
5 point what?
07.
About 5.1. So air oxygen ratio, just plug and chug. Air. $38. Now we are. Gotta use 20. 100 minus 38 over 38 minus 20. 62 over 18. About a 1 to 3.44. All right, let's do 50. So we got 100 minus 50 over 50 minus 20. 50 over 30. So about 1 to 1.66. Not too bad. Air oxygen. Yeah, you're just gonna take a picture of it and submit it in Professionalism Week 1. So once you're done with tomorrow's handout too, just take one image, all 5 pages, and just give me one image. Yeah. No, I'll show you guys how to do that on by Thursday. So by Thursday. Dead space volume. So from your lips all the way down to your alveolar sac, you have space for gas exchange, but there's areas, volumes, that will not be involved in any gas exchange, and that is called the dead space. So when you inhale some air, let's say a liter of air, some of that is going to be in that dead space and is not involved in any gas exchange. So we need to eliminate that from our equation. So about every pound of body weight, you have about 1 millimeter, 1 cc of dead space. So you guys know how to convert from kilos to pounds, right? Yeah, it's just the opposite. So instead of dividing by 2.2, we multiply by 2.2. So if you have to. So that's just the estimate. All you do is plug and chug. So here is your pressure, your CO2 pressure, and here is the partial pressure. So we must solve for the dead space, right? VT is total. So all you do is dead space over the total. So it's plug and chug. So A, so the partial pressure of carbon dioxide is 40. The measured, or the average, is 15. And you just divide that by the partial, which is 40 again. So simplify that. What's that? 25 over 4. How much? 0. What'd you get? 25 over 40? 0.625. If if I need to turn that into a percentage, how would I turn that into a percentage?
10 to 100.
Yeah, times it. So that's if you need to turn it into a percentage. All right, B. So the partial is 43. All we do is subtract the average over 43. So your ratio becomes 0.41.
Can you go over how I missed how you do this? Just one more time.
Okay, so PA is the partial pressure. So they're going to be labeled for you. All you have to do is plug and chug.
Okay.
So for you, it's probably too many COs. So just look for the PA.
Okay.
So that's going to be 40. Anytime you see a PA, plug in 40. So for this one, plug in 40. And then for this is PE. So anytime you see the PE, plug in the value for PE, which is 15. So we got 40 minus 15. And then down here, it's just the partial again, which is 40. That's all you're doing.
Okay.
And then what I did is I simplified. 40 minus 15 was just 25. So the values are given, you just got to plug them in the right place. All right, now we have to take in account the dead space. So you have to subtract out the dead space. So every pound, there's about 1 cc. So this is total. What's the dead space? How much dead space is there? If 1 pound equals 1 cc, there's going to be how much cc is dead space? 1 pound equals 1 cc. 175 equals? It's a 1-to-1 ratio, guys. 1 pound equals 1 cc. 175 pounds equals 175 cc's. Sometimes it's too easy. All right, so what's my dead space value? 175. So 175 divided by 600. That's it. kgs. How many pounds is that? Multiply or divide by 2.2? All right, let's set this up. So we got 90 kgs. So you got to know your conversion factors. Just refer to the list. For every 1 kg, there's 2.2 pounds. So the kgs cancel out. 90 times 2.2. What do you get? How many pounds is that? About 202.5. So that means how much cc of dead space is that? Yeah, about 203. All right, we'll round up to 203. All you got to do now is plug in 203 divided by 550 times 100 to get the percentage. So it's just algebra. Plug and chug, rearrange to get the value you are looking for. Fraction, which gives you a decimal, and then when you multiply by 100, that gives you percentage. So all you got to do is make the fraction times 100. Super easy. So for A, what's my numerator? 20. What's my denominator? 44. And to get percentage, you multiply by 100. That's it. Relative humidity is pretty easy. So depending on the temperature, there's only so much water vapor that can be held in it. And usually it's not 100% saturated. It'd be very difficult for us to breathe. Too much moisture in the air. So it's relative, based on how much can be held at that temperature. So what percentage is that? For A, what'd you guys get?
44.
Ooh. Yeah, it's muggy, super muggy. All right, for B, do the same thing. Plug in the numerator, divided by the denominator.
You need 20, the top one, you need 20 divided by 44 and then times it by 100.
Yeah, for the top one, yeah. Numerator, divided by times 100. So for B, 15 is the content, 47 is the capacity, times 100 to get percent. This is a little better. 30?
31.98.
About 32. Yeah, we can round to about 32%. A little bit better, but still nasty. That's nasty weather. So we have to subtract water vapor depending on the temperature to calculate non-exchange. All right, lastly for today, last topic. Watch your mouth. Lung volumes and capacity. You're learning. All right, so we'll do the homework for homework. So give it a try. Do your first attempt. We'll do the second attempt together in class tomorrow.
Chapter in the book this is in?
If you go here, I got some page numbers. So in the parentheses, you'll see like for IE ratio, page 24, air oxygen 20, dead space, page 27, etc. Yeah, so just refer to those. They should correspond with your current text.
When is this assignment due?
Supposedly in about 10 minutes. It's okay, just do it for homework. We'll go over it tomorrow. All right, so just get familiar with the names for the different lung volumes. You're going to be able to have the chart when you take your quizzes and exams, so don't worry about trying to memorize everything. Right? So the goal when you're solving these problems is, you see those bars? All those bars must be equal. So you try to solve for the value of the bar. Once you know the value of the bar, then you can figure out the values of everything else. Right? So it's plug and chug, but we have to do it visually. It's going to be a lot easier if you do it visually. All right, so let's plug in our known values. VC is 4,800. So I'm just going to plug in 4800 here. Right? IC is 36. So IC is 36. And the other information they gave me, TV, tidal volume is 500. So I'll label that 500. And reserve volume is 1200. All right. Do I know the value of a bar?
TLC.
What's the value of a bar? Do I have all the information to figure out what one bar would equal to?
7,200.
So look at this guy, right? I know 1200 plus 48. How much is that? Total of how much? Count them. Punch it in. 1200 plus 4800 is 6,000. All right. So we know that TLC also equals 6,000, right? So one bar, all bars must equal 6,000. So we figured TLC. Right? So it's a lot easier if you do it visually.
You're adding RV and BC.
Yeah,
That's
yeah.
what you just did.
Yeah, the value of one bar, one entire height, is 6,000. We solved that.
One column.
Yeah, one column.
And you add each one of those to get a value, or to get a value for that column.
All columns must equal 6,000. All right. So that's the first thing you need to try to figure out, is the value of the column. So because we figured out, we know RV and VC, we add those together, that's equal to TLC. Right? So now we know the total lung capacity, we can solve the other portions. So everyone solve for FRC. This should equal 6,000, right? So 6,000 minus 3,600 would equal 2,400. Very good. FRC is 2,400.
And that's all gonna be milliliters, correct?
Yeah, they're all mLs. All right, what can we solve next? Let's solve this guy. Now, we're not going to solve the whole entire column. We just need to know this value. So now we have two miniature columns. So IC is 3,600. So I know 500 plus IRV must equal 3,600. So what is this value here? This guy and this guy must equal the same. So IRV would equal how much? What number plus 500 would equal 36? 24, are you sure?
Wait, I'm sorry.
19, are you sure?
You want to find out
IRV, right? So I know this column is 3,600.
3,100.
This also needs to be 3,600.
Oh.
So this is 500. How much left to get to 3,600? 31. There you go. Very good. So IRV is 3,100. And then the last thing we need to solve for is, oh, RV, I forgot to. So RV is in two places. So now this column, right, these two columns are 2,400. This guy's already 1,200. So what's left over? 1,200, right? So this guy and this guy must equal the same. All right. To double check, add up all your columns, make sure they all equal 6,000. Not too bad. So it's like a little puzzle. If you guys like Sudoku, this is a lot easier. All right, let's do the next few examples. All right, let's plug in our known values. VC is 4,000. IC is 2,800. Tidal volume is 600. And our reserve volumes are 500. Do I have a value of one of the columns? How much? So the first one. So what's this column's worth? No, this one, the new example. So this column is 4,500, right? So now we know everything must equal 4,500. So TLC is 4,500. So that guy is just 4,500. Easy enough. All right, solve FRC. So this should be 4,500. 2,800 plus what number will give you 4,500? 1,700. Very good. So FRC is 1,700. All right, let's solve this guy. So this column here, the lower column, the smaller lower column, should be 2,800. 2,800 minus 600 equals, try again. 28 minus 600 is? 22, there you go. Ooh, I forgot a 2. There you go, 2,200. And the last volume we need to solve for is ERV, expiration reserve volume. So we know that this is 1,700, this is 500, so this guy needs to be 1,200. Double check, make sure all your columns are the same. They all must equal 4,500. All right, I'm gonna let you guys do that last one. You can do it. All right, everybody. Plug and chug. Plug in your known values. And then solve for your unknowns. A little bit different. 5,000 there. FRC 2,000. Tidal volume is 400. Reserve volume is 800. Oh, Mr. Dang. Why'd you make it so hard for us now? Alright, solve this guy first.
4,000.
Solve this guy second. I think you guys got it. How'd you guys do? Excellent.
Started okay.
Started okay.
Yeah.
Yeah, and then I just.
Well, I mean, I couldn't. I just haven't got it finished.
Keep on, keep on.
Yeah.
All right, your access code for the assignment 1.1 is decimal. Decimals.
One decimal?
Yeah, that's your access code for assignment week 1, day 1. Decimals.
No capitals or just
1.1.
I think it's all lowercase. We'll